Hello everyone, my name is Annesha Naha, currently pursuing Bachelor's of Technology in Computer Science and Engineering from Lovely Professional University. Today I will be going to present my project on Virtual Memory Simulator, which demonstrates how memory is managed efficiently using paging and replacement algorithms. So let me begin by explaining my project, which is a virtual memory simulator. This project demonstrates how OS manages memory using page replacement algorithms, paging and demand paging like LRU and optimal. So the main aim of the project is to provide a visual and step-by-step understanding of how page hit, page fall and memory replacement occur in real systems. So by experimenting with different inputs, we can clearly observe how memory constraints and algorithm choice affects efficiency. So now I will be explaining the working of the whole simulator. So pointing towards the screen, this is the whole interface. On the left, we have the input controls like process size, page size, number of frames, algorithms and reference string. On the right, we have virtual memory, physical memory, and below we can see the reference string and system logs. Now, here the process size and page size determine the number of pages. Physical memory is divided into frames. The reference string represents the order in which pages are accessed. Now, I'll click next step to simulate the execution. At each step, a page is requested from the reference string. If the page is already in memory, it is a page hit, and if it is not, it is a page fault. If there is empty space in memory, the page is loaded directly, and if memory is full, a replacement algorithm is used. And the algorithms in LRU, the least recently used page is replaced. In optimal, the page that will not be used for the longest time in future will be replaced. The frames in the visualization shows which pages are currently in RAM. Green indicates a hit and red indicates a fall as shown in the simulation. The system log shows each step clearly. And now the internal fragmentation is shown in the last page when memory is not fully utilized. We can also see the total page hits, page falls and the hit ratio uploading in the real time in the simulation. This project makes it easier to understand how virtual memory concepts visually and interactively. So now I will be setting the inputs before running the whole simulation. Now I will be setting the process size to 8. Next, page size as 4, frames as 3. Algorithm I will be using now will be LRU. The reference string will be 0, 1, 1, 0, 1 and 2. I am setting up a simple example to demonstrate how the paging actually works. So now pointing to screen, virtual memory shows page 0 and 1 and physical memory shows empty frames. Initially RAM is empty and no pages are loaded. Now I will be clicking the next step to start the simulation. I'll be clicking once. Page 0 is requested. It is not in the memory, so a page fault occurs. It is loaded into frame 0. Fault count increases. Clicking again. Page 1 is requested. It is not in memory, so another page fault occurs. It is loaded into frame 1. I'll be clicking it for the third time. Page 1 is requested again. It is already in memory, so this is a page hit and it will be highlighting a green effect. Clicking for the fourth time. Page 0 is already in memory, so this is also a hit. Clicking again. Page 1 is found in memory, resulting a hit. So clicking it for the sixth time, page 2 is requested and it is not in the memory, so a page fault occurs. Since a free frame is available, it is loaded into frame 2. Now the final output will be, here we can see total page hits, page falls and hit ratio calculated in the real time. Now I'll be changing the reference string to 0, 1, 2 and 3. So 0 is fault, 1 will be fault, 2 fault, that is memory is full now, and 3 have fault plus replacement. So now the memory is full, so the LRU algorithm replaces the least recently used pages. Now from LRU I am changing it to optimal. Now I switch to optimal algorithm to compare the behavior between LRU and the optimal. So performing the same steps again, point to the log section. Each step is recorded here, showing hits, faults and replacements clearly. And I'll be changing the process size from 8 to 10, page size to 4. Here we can see internal fragmentation in the last page. So this demonstrates demand paging, page replacement and memory management visually, and after comparing LRU and optimal we can clearly see the differences between them. So concluding all this, it demonstrates the concept of virtual memory management using paging. It clearly shows how pages are loaded into physical memory using demand paging and how page faults and page hit occurs during execution. The implementation of LRU and optimal also helps in the better understanding of how different page replacement strategies affect the performance. Thank you.